Alright, so today we're going to be doing 8.4, which is going to be geometric series. So you all know what a series is. That's where you take the terms of a sequence and add them up, and the sum is going to be the series. So we did arithmetic series yesterday, where you take the terms of an arithmetic sequence and add them up. So a geometric series is where you take the sum of the geometric sequence terms and add them up. Okay? So in this case, if we want to convert this geometric sequence right here to a geometric series, we would simply add up all the terms, which would give me 77.5 as my sum. Okay? Alright, so unlike with arithmetic sequences and series, we have only one general rule that works here. Hang on. Okay, so I was just saying that we only have one general rule, but we have these other formulas that can be used to find missing information. Figure that we need to have one of those pieces of information that we're missing. Those are the formulas we're going to use. So say you're missing an A1 or an AN, you need that material or that information to plug into the formula. You're going to use these two formulas to do that. Now, technically speaking, these are actually the same formula. They are just manipulations of each other. So I'll just talk a little bit about this. You don't have to write this down. If I divided both sides by a sub 1, I would end up with a sub n over a sub 1 is equal to r to the n minus 1 power. What do we have to do to both sides of the equation to get rid of an exponent? We have to take it was our whole last chapter. The ln or the log. In this case, log, no e's. And that's how we get with the log. So I just wanted to show you how that formula transforms into the other. You don't have to, like I said, write this down. I'm just trying to help you make those connections. All right? So with that being said, let's go ahead and look at the first question. First thing you always want to identify is the first term. What is the first term here?
3.
Good. What is the last term?
3072.
Good. What is the common ratio?
2 times
2. Very good. Because it's getting multiplied by 2 every time. Remember, geometric sequences and series have multiplication instead of addition. Okay? So if you look at the sum formula, we have almost enough information, but what variable are we missing? N. We don't know n, so we have to find n by using the formula that helps you solve for n, this formula right here. So we're going to plug into this formula to figure out what n is. So n is equal to log of your last term divided by your first term over log of r plus 1. Once we have that, I'm going to put it in the Desmos calculator. So I'm just going to clear everything out. And I just go to function, I hit the log button, and I type in 3072 divided by 3, still inside the log at this point, divided by log of 2, and then I click out front to do the plus 1. Okay? So if you do that correctly, if you type it in correctly, you should get 11. Good. So n is 11. Now that we know what n is, we can plug into the s sub n formula. So s sub n, s sub 11, is equal to your first term times 1 minus r to the power of n all over 1 minus r. Okay? So I go back to my Desmos calculator.
Can you move it?
Yeah, don't worry, I got you. So I'm going to try to type this in while this is up. So 3 times parenthesis. You have to put the double parentheses in here, and you're going to see why in a second. 2, and then the a, b gives you power of anything you want. Then I click outside those parentheses and hit the division button. Because if you don't put that there, it's going to try to do division just over one of the terms. You'll kind of see when you play around with it what you have to do. And when you do that math, you should get 6,141.
Is this complicated? It's like how do you use the Desmos thing?
I got negative 6,143. Negative 6,147.
I'm going to guess that you didn't put parentheses around this when you did it in your calculator. If I had to make an educated guess. So all you have to do is, that's why I recommend you use this Desmos calculator over the, like the hand ones, because I can visually see and make sure it looks like what it should look like. Do you see what I'm saying?
Yeah. Is there like a written down formula, like right here is the formula for both the things we just used?
Yes.
Okay.
Okay. You'll start getting the hang of it as we do problems. It's not so bad once you get the hang of it. And I'm going to show you a few tricks and tips as we go through as well.
Also, last night's homework I had a problem with one of the word problems, and or actually both word problems. So
Yeah, at the end we can do it if you want on the board. That's fine. All right. Any questions about 1? Are we good to move on to 2? Okay. So in number 2, if we look at the S sub n formula, what thing are we missing that we don't have here?
The first one.
The first term. Very good. So luckily we have a formula that can help us find the first term. Now either one of these formulas we can plug in to find the first term, but why would I choose the one on the left over the one on the right?
It's a lot less complicated.
A lot less complicated, exactly. So I'm going to take this formula and I'm going to plug in what I know. Okay? So I just plug in what I know. Everybody see what happened there? I plugged in for A sub n, I plug in for R, and I plug in for n. And now I don't know A1, so I'm going to be solving for A1. So what operation in math reverses multiplication?
Division.
So I'm going to divide both sides by -2 to the 9th power. Everybody see how I'm able to simplify that that's the 9th power? 10 minus 1. That's where that's coming from. I'm just, instead of writing it out as a whole new step, just so I can save space. Now this can now cancel out, and A sub 1 is going to be equal to whatever this division is. So like I said, I try to let the calculator do as much work as possible to avoid the work I have to do. So if I hit enter here, I can get a new line. That's going to give me, bless you, negative 2,560 divided by -2 to the power of 9. Thanks. 5. You should get 5. So now that I know the first term, I can go ahead and plug into the formula for S. So S sub n in this case is 10, is equal to my first term times 1 minus.
I have a question.
Sure.
Is this a different formula for finding A sub 1 than it would be for like finding n, or is it just like?
Yeah, so these, like, that's what I was saying. These are technically the same formula. They're just solved for a different variable. It's just
Right.
that we're using more complicated math because the variable is in the exponent. So you can technically use either one of these formulas to solve for any of those variables. It's just going to be easier to use one than the other in certain circumstances.
Okay, so like, so the formula for A of 1 or A sub 1 is the same as the formula
For n. Yes.
Alright.
Okay, so here's the
So,
general rule of thumb. If you're not solving for n, use this one when you're solving for R, A1 or AN. This is the only time you want to use this version of it is when you want to solve for n. It's easier to use this one.
So since we already have n and A, and we just need to find A1, we use that same formula.
Exactly.
Okay.
Exactly. Yep. So you're only going to be missing one piece of information. They can't have you missing more than one or you couldn't solve it.
Right.
Right. So I just plug into the S formula. Now that I have all the information I need, I can find the sum. So when I go to put this in the calculator, oops, this is the one I want. Here's the trick that I want to show you. See how I already did this calculation earlier? All I can have to do now is change the numbers. See how you don't have to redo all of that every single time? Well, I gotta take this other part out, of course, but. So, that's my recommendation too on tests and quizzes, is I can always, that's why I recommend using this calculator, because it's one of the only calculators that will allow you to do this, okay? So I can go back in and just change the things I want to change, and that saves me a lot of time in typing stuff in, right? So I get negative 1,705. Okay. So do you see the benefit in that calculator being able to just change the few things you need to change? So, Are we good with how to do that? If you're having trouble with that one, if you want to use that calculator, at the end I can help you go through a problem if you want.
That would be very much appreciated.
Okay. So now we're going to talk about a summation. We learned about what a summation is yesterday, right? Not much has changed in terms of how a summation works. This is the rule that the summation takes. In this case, this rule happens to be geometric instead of arithmetic, okay? So basically, you're plugging in the first term, then the next term, and so on, and then adding those terms up. That's how the summation works. Same rules as before. But here's what's really cool about geometric sequences over arithmetic. I'm going to show you really quick. So the cool thing about it is, let's take a look at this general formula here, and then take a look at how it's written. Can't you just visually see what each one of those things are by just looking at the formula? That's what's really cool about this, as opposed to arithmetic. We have to plug values in for arithmetic, but with this one we can just see. What is A1 here?
3.
Good. What is R? 2. And then N is the one that's always tricky. It's always the limit, the end 12. It's always the top index there. Okay? So you see how I didn't have to plugging anything in this one because I can just see what's going on right off the bat. So work smarter, not harder, right? Now that I know, instead of me plugging in 1 through 12 and adding them up, what's a faster way we can do that? Use the sum formula, right? So the sum of the 12 terms is equal to your first term times 1 minus r to the power of n over 1 minus r. And as you know, I like to use a lot of parentheses because better use more than not enough. It's my philosophy. Luckily, I already have it typed in, so all I have to do is change the numbers. And I should get 12,285. Okay. So like I said, it can really be helpful to use that calculator. Any questions about number 3? All right, number 4. Looking at it, what is n? Anyone know?
8.
Good. What is A1?
4,000.
Good. And what is R?
0.5.
Good. 0.5 or 1/2, however you want to write it. Now we have all the information needed to plug into the sum formula. So the other way you could have done it was to plug in 1 through 8 into the formula, add those up. This is easier, so we do the easier route. I want to find the sum of all 8 terms, and that's equal to my first term times 1 minus r to the power of n over 1 minus r. So once again, calculator, pull it up. I just change the numbers I need to change. and you should get 7,968.75. Any questions about that? Okay. So that's all I have for you. There's one last thing I want to mention before you get started on the homework.
Wait,
Yeah, I'm gonna do that after this.
I missed,
Okay. You go ahead. Copy it down.